Okay, a rock is thrown vertically upward. So it's going to have a positive velocity, initial velocity, from the surface of the moon, velocity of 24 meters per second, great. Reaches a height of a position function, S of t equals negative 0.8 t squared plus 24t, meters and t seconds. The way they write things sometimes is a little confusing. Okay, we know it's a position function. The units are meters per second. We know that 24 that's written for us, that's the initial velocity. It's positive. It's shot upwards. We can get that from the function. Okay, and then the gravity on the moon's surface will be twice this amount, right? Negative 1.6 meters per second. Okay, a little bit less than Earth. So, should you be able to throw a rock higher than on the moon? It should take a lot longer to get up there and get back down, right? Okay, find the rock's velocity and acceleration as a function of time. That's just a fancy way of saying, give me the velocity and acceleration functions. Okay? All right, v of t equals s prime t. We're writing that out every time when we find our functions anyways. Would that be negative 1.6 t plus 24? And what would the units be on velocity? Not feet, meters per second. Yep. Okay, acceleration, a of t equals v prime t equals, would that be negative 1.6? Okay, just like we thought. Okay. And that would be what, meters per second, meters per second squared. All right. How long will it take the rock to reach its highest point? How long means t equals something when, what do we think here? In terms of calculus, when do we know something's at its highest point? Okay, velocity equals 0. V of t equals 0. So let's find when v of t is 0. We have our v of t function over there. 0 equals, and this isn't too bad, t equals what, negative 24 over negative 1.6. Is that correct? And what are you guys getting? And units? All right. It takes 15 seconds for this object, this rock, to reach its maximum height. What was it before? 3.5? That just seems like crazy if you can throw something 15 seconds straight up. This is insane to think about that. All right, how high will the rock go? So what are we finding then? Position at what time? All right, this is find S of 15 then. Units, what would they be? If you don't know, where would they be? Where would you find them? Position though? Meters, yeah. You guys get 180 meters? Again, that's kind of crazy to think about. You can almost throw a ball or a rock 2 football fields vertically. It's crazy. How long did it take the rock to reach half its maximum height? So how long, so that's t equals, we don't know when S of t equals what? Half its height is 90, right? So we want to know the time when S of t equals 90. All right, let's do it. 90 equals, we got negative 0.8 t squared plus 24t. Ooh, this is a quadratic. We are not factoring a t out and dividing, but we are not doing anything crazy. We know we have a t squared term and a t term, so we're moving everything to one side. Now, you can use your calculator to find the roots. And probably the first t value when t equals 0, right? Right. Or you could set 90 equal to t sub y sub 1 and the position function equal to y sub 2. Find where they intersect. Either way, use your calculator though. Find those zeros. We did that at the beginning of the year, correct? This would be a calculator one. And usually they're worse than this. It's like 15x sine squared of 3 pi x or something like that. Well, it's the same deal. You just put in your calculator and you look for the same thing. So we're entering the function of y1, finding the zeros.
4.39 or 25.6.
And then, or 25 point. Give me the, is there more?
6066.
There we go. So remember, always, always, always round 3 decimals, truncate 3 decimals, either or. Okay. Now we're just gonna go with the first one because I'm just gonna assume that it's going up, right? Okay. And we could, in context, you will understand which one to use or use both of them. Okay. All right. Oh, we better label seconds, I believe, right? How long was the rock aloft? How long was that rock in the air? Well, critical thinking, we think we can come up with the answer pretty quick, right? What should the answer be? What do you got, Kobe? Yeah, it should be 30. Why? Yeah, so it should take 15 seconds to come back down again, right? Okay, so what are we going to do, though? That's when S of t equals 0, right? Well, let's find that. This isn't too bad. Well, it should be negative, right? So 0 equals, factor a t out. And again, I could factor out negative 0.8. I don't want to, though. So t equals 0. Obviously, that should be clear to us. Or t equals, would that be if we subtract the 24 and divide it by negative 0.8? Are you guys okay if I don't set up 0, 8t plus 24 equals 0 every time? I kind of do the math in my head a little bit. I mean, that was algebra 1, algebra 2 for us, right? And is that 30 then? Okay, again, how are we going to get some points for this? We're going to show our initial relationship right here and then get an answer. Okay. And conceptual understanding is going to be really good for you guys, especially if you go off and take engineering physics or something else next in a couple of years, even next year. Find the rock's speed. All right, absolute value of V of t when hitting the surface of the moon. So that'd be V of what? 30? What should it be? What should this answer be before we even calculate it? It should be 24. Maybe you said negative. What would be negative? Negative 24. The speed will be 24, but what will be negative 24?
The negative sign.
No. It'll be velocity, right? It'll be negative velocity because it's traveling back downwards at 24 meters per second. We take the absolute value of that. Use your calculator, figure that out, make sure it equals negative 24. And we should have 24 meters per second, right? And some of the stuff, guys, is showing you guys that the math works for the theory, right? Questions on this at all right now? Are we good? All right, how about this ball? How long will it take that ball to hit the ground if we drop something off the Washington Monument, which is 555 feet high? Ball is dropped. What does that tell us when they say dropped?
Velocity is 0.
So V sub 0 equals 0. Okay, you got to be able to pull these things out of the stem, out of the question. What does 555 stand for? S of 0 or H of 0? Yeah, I'll take either one. All right, now they gave us feet, so we need to use feet per second for our velocity and feet per second for our acceleration. So our initial position function, or our position function, I should say, is negative 16 t squared plus, I'm going to say 0t just for fun, plus 555. And then our position function is negative 16 t squared plus 555. I like that when that middle term is 0, when something's just dropped, it makes the math pretty convenient for us. How do we know when this thing hits the ground? S of t equals 0, right? So let's set x of t equals 0. 0 equals negative 16 t squared plus 555. So t squared equals if I cancel out my negatives, quick 555 divided by 16, and then square root, and then second answer. That second answer button should be, what's up? That's our acceleration. That's our model from right here.
So that's what it's like
always with, for we're talking in feet. And it'd be negative 9, I'm sorry, negative 4.9. 4.9 t squared plus v sub 0 t plus s of 0 if we're in metric. Are you guys getting 5.889? With some change, right? Okay. Find the ball's speed at impact. Ooh, here's a problem though, guys. We're going to be finding absolute value v of 5.889, right? Problem is, this is a rounded answer, right? If this is a rounded answer, that means this is going to be a rounded answer. I wish there was a way in this calculator that we could just like store some values. Bottom left-hand side, right above the on button. See STO with an arrow? Hit that once. After you have like the absolute value, or sorry, the square root of 55 divided by 16. I'm not going to do it up here because it's going to freeze my writing on that. If I hit store, and it has an answer, then the arrow, right? That means the last answer we calculated, which is at 5.889609495. You can store that somewhere on the calculator. I like to store A. I'm just going to first find the velocity function. V of t equals s prime of t, negative 32 t, right? And then absolute value v of 5.44 or 889. So negative 32 times a. That gives me negative 188.467. Well, now I know the absolute value is 188.467 or 468 if you round, and feet per second.